welcome everybody. Okay, so what we're going to be doing today are mole conversion notes / worksheet. The worksheet part of it is simply whenever you see the oyo, which is like the on your own part. So you can see like at the bottom of this page, I don't see any oyos. But if we come here, you can see that there's question 1, question 2, question 3, and then we've got some oyos there, okay? So we're just going to start off on part 1 just with this first page. We're going to talk a little bit about the mole. Some of it's going to be review. So let's get started. Okay, so the first thing is, what is a mole? So we've talked about this before. We said like a dozen is how many? 12. A dozen is 12. Everybody knows a dozen is 12. How much is a mole? 6.02 times 10 to the 23rd. Go ahead and box that in, okay? We are going to write it a few times because I do want to make sure that you remember what that number is. This is also known as not avocado's number, it sounds like it, but Avogadro's number. Everybody say Avogadro's number. Avogadro's number. Okay, and so now we're going to write out the number. It's going to be annoying, but I want you to write it out for a reason. I want you to see how long this number is. So what you're going to do is you're going to do 6, write small, 602, comma. Now I want you to do 21 zeros, 21 zeros. And it's 6.02 times 10 to the 23rd, but I already have 2 numbers here, so I'm going to go 1, 2, 3. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Go ahead and do your 21 zeros. That's how big Avogadro's number is. Now, when we talk about the dozen, you could say dozen of what? Like, what are some things that you would talk about having a dozen of? Eggs. I like it. Donuts. What else? Donuts. Good. Maybe if you're like, I need a dozen. Bagels, pencils, maybe something like that, right? We all know that a dozen is always 12, right? And what we had said before was that the dozen doesn't tell you anything about it. It just tells you how many you have. So, for example, if I said, what's similar about a dozen pencils, a dozen cars, and a dozen strawberries? What's the only thing that's the same about them? That you have 12. Nothing else is the same, okay? So it's going to be the same thing when we talk about the mole. The mole is simply an amount of something that you have. Well, what would we ever have this many of? Nothing that you could see with your eye, nothing that you could see with a microscope, but something really, really small, like what? Atoms. Like ions or like molecules. Those are going to be the things that we have a mole of, okay? So I want to show you what a mole looks like in just a little bit, okay? So how do you figure out the number of atoms? Not the mass, but the number of atoms. What we're going to do is we're simply going to use Avogadro's number. Avocado is like similar. Avogadro's number. 1 mole of different substances can have different masses and different volumes, but the number of particles has to be the same. So this right here, the number of particles has to be the same as long as you have 1 mole. In other words, if I asked you how many particles were in 1 mole of silver, what's the number, everybody? 6.02 times 10 to the 23rd. Awesome. What do you think, how many particles are in 1 mole of salt, of NaCl? 6.02 times 10 to the 23rd. What about a mole of nitrogen? 6.02 times 10 to the 23rd. I do want you to write it 4 times, okay? I really do. I want you to write it 4 times because then you won't forget it. So the more you write it, the less likely it is that you're going to forget it, okay? So that's how many particles there are. Now, how do we figure out the number of atoms? Well, we figure it out based on the mass of it, okay? So what we do is we take a look at the periodic table, and we looked at this before, and what we had said was hydrogen, for example, weighs how much for 1 mole? 1 gram. 1 gram is 1 mole. So what if I wanted 3 moles of hydrogen? How much should we weigh? 3 grams. And if we wanted 10, we would do 10 grams. Okay, so that's how we would do hydrogen. Let's take a look at something else here. Let's take a look at oxygen. Oxygen's mass is about what? 16, right? 15.99, which would be like 16, right? Okay, so if I had 2 moles of oxygen, though, then it would actually be 16 times 2. That's how you'd figure out the mass, okay? Or what I could do is, for example, let's say I had helium, and let's say that I had a balloon and I filled it with helium and I found out that it weighed, I don't know, 12 grams. And I wanted to know how many moles that is. If it weighed 12 grams, anybody know this? How many moles would that be? 3. That would actually be 3, okay? Okay, so let's take a look over here. And this simply says, so how do you figure out the mass of a sample? In order to figure out the weight, we simply use the periodic table. We're going to use that red number in the top right corner, and the weight of the number of particles is expressed in what are called AMUs, or what we say is grams per mole. We're going to abbreviate it. Please make sure you use your abbreviations, and it's gram per MOL. And I'm going to talk about this symbol in just a second here. Okay, this is also called the molar mass. If I asked you to define molar mass, which you will need to, okay, the molar mass is simply defined as the mass of, anybody want to guess? If it's the molar mass, it's the mass of 1 mole of any atom, okay? So for example, all of the numbers they got were based on carbon, and carbon is 12.017 grams per mole. That's how many grams are in a mole, okay? So each substance has a different atomic weight based on the elements that make it up. So because of this, the mass equal to 1 mole could be different for all the substances. All right, this is the time to show you what a mole looks like, okay? So let me just increase this and then we'll come back in just a second. Okay, so let me show you first. This is sulfur. I don't know if you could tell, but it's just on the bottom right here, so it's just on the bottom here. That's a mole of sulfur. Let me show you a mole of salt. This is a mole of NaCl, of table salt. Okay, that's a mole of it. This is a mole of sugar, and this is a mole of something called copper sulfates. This is a mole of water, okay? What is the same about all of them? Well, let's first talk about what's different about all of them. Water is a liquid, right? This one is salt, okay? And this one is white versus this one being blue, and these are more like crystals, okay? They're all different. Sulfur is like a yellow powder. Just like the dozen, what's the only thing that's the same about these? They're all 1 mole, which is how many? 6.02 times 10 to the 23rd. Perfect. That's all that is, okay? Now, that's how many atoms. We can see this. Why can we see it? What a mole is? Because the atoms are so small. The molecules are so small. But this actually has billions and billions and billions of water. So the question is, I'm the one that made these. How did I make these? How did I make these containers? How did I figure out that this is NaCl versus this one is sugar? Okay, so somebody wants to guess, if you want to take a guess.
Obviously counted.
I counted something. Okay, yeah. So I sat there and was like, 1,000, 2, 1,000. Yeah, I was sitting there counting until I got to 6.02 times 10 to the 23rd. I like it. Obviously, I didn't, right? Because that would take me, I would be not around on this planet at least, right? So what do we do instead? We have to look at the periodic table, okay? So let's take a look at the periodic table to see how is it that we figure this out. All right, so helium. Oh, let's look at this first. Helium is 4. We already looked at helium, and we said it was 4, so we call it 4 grams per mole. I don't have helium here, okay? Oxygen gas. If I wanted oxygen gas, why isn't it 16? When we looked at the periodic table, we said O was 16. So why is it 32? Oxygen in nature is not actually O. What is it? It's O2. So we actually have to divide, we have to multiply it by 2 in order to get oxygen's mass. The next one we have is water. We know that hydrogen is 1 and oxygen is 16. But what's the formula for water? H2O. So on the count of 3, I want you to tell me what the total mass would be of 1 mole of water. On the count of 3, 1, 2, 3. 18 is the correct answer. Why is it 18?
Because you have to do 1 times 2.
Yes, there's 2 H's and how many O's? 1, and you add them up, and you get 16 plus 2, which is going to be 18. All right, so let's write 18 in this blank right here, which is 18.0 grams per mole. Okay, last one. Rock salt is MgCl2. If Mg is 24.3 and Cl is 35.5, let's write down what we put in our calculator. So it's 24.3 plus what?
No, we have to multiply by 2.
Multiplied by 2. Very good. Because of this 2 right here, what I'm going to do is I'm going to say 2 times 35.5. So you can plug it in your calculator. That's 71, 81, 91 plus 4 is 95.3. You would do it in your calculator. And again, that's 95.3 grams per mole. Okay, let me talk about this for one more second. So water here, the way that I figured out how much went in here is I either could weigh 18 grams happens to be that for water, the density of water is 1 gram for every mil. So a gram and a milliliter of water are the same. That doesn't work for any other substance. So I literally could either measure it in milliliters or I could weigh it and get 18 grams. Let's look at the periodic table. How do you think I got how much to put in sulfur? How much do you think I put in for sulfur?
32.0.
Yes, I put 32.1 grams in. That's how much it was for the sulfur. Okay, so the sugar, the reason why the sugar is so much, well, let's compare salt and sugar. Salt is NaCl, so I would have to add up 1 Na and 1 Cl. Sugar's formula is a little bit crazy. Does anybody know sugar's formula? For sugar is C12H22O11. So what that means is if it's C12H22O11 is sugar, I would have to multiply 12 carbons, they're each 12 apiece, 12.01, 22 hydrogens at 1 apiece. Who remembers what oxygen's mass is? 16 times 11. So this actually ends up equaling, I think it's like 342, I wrote that, 342.22. That's how I figured out how much went in there, okay? That's why they all weigh different amounts. So even though it's the same amount of particles, like if I counted them, they each weigh a different amount. Just like if I said, how much does a dozen weigh? Well, you can't say that, because are you talking about a dozen cars, or are you talking about a dozen donuts? A dozen cars are going to weigh a lot more than a dozen donuts, okay? Last thing is this. When you look at anything that has a dash in it, for example, I could say 60 seconds per minute, okay? This slash right here could actually be an equal sign. In other words, this is the same thing as saying 60 seconds equals minute. If there's no number in front, what is it?
1.
A 1. So that means 60 seconds equals 1 minute. There's another way of writing this. I could write 60 seconds per 1 minute, or I can have this flipped. But would it be correct to say 60 minutes per second? No. That doesn't make any sense, okay? So just keep in mind that as we move into the second part of this, you want to make sure that it makes sense. And so these slashes can also be what? Written as what? Equal signs. Awesome, okay? All right, I hope you got what we did in this first part, and we'll be moving on to the second part very soon. Happy day.